Okay, great. So, ladies and gentlemen, we're going to add a new model. How do we add a model in AnyLogic? The palette stands before you, a tabula rasa. How are we going to create a new model? File new. File new model. And this is going to be called, oh, I forgot to upload the model from yesterday. I promise I'll do that. Great. So we're going to call this smoking and heart disease. Okay? I'm going to call it version 1 because I'm going to upload this as we proceed, if I'm sufficiently mindful of it. And the time unit associated with this model, it bears being careful about what the time unit is from the very get-go. The time unit of this model, ladies and gentlemen, is years. So I'm going to say finish, and it will actually go create this model. Okay? Yeah. Do I want to save it? Yeah. Okay. Okay, so you create it, and what lies in the model? Well, main, the stage in which the agents will strut, this kind of overall global environment, and simulation, which is a what? What is simulation? X marks a spot to indicate a what? Experiment, thank you. Spared my ear. Okay, good. So, ladies and gentlemen, we are going to, first thing we're going to do is we're going to add a person to this model, okay? How are we going to add a theory of personhood? What do we need to do? We add a what? Agent type, right. The thing that describes personhood. So we'll do new agent type, and it will be called capital P person. Okay? Here we go. Person. Let us lend that person a face upon the world. Okay? To do that, we can double click on person, just make sure person is selected, and we're going to give them an appearance. And the appearance here will be one, and I'd like to show this to you, so I think I'm going to do it. I'm just going to drag in this person shape over here. This person shape is recommended by aesthetics, but is not recommended for being a little bit more painful to manipulate its color. But it does allow us, for example, to set their head to be a different color than the rest of the body or what have you. So I just dragged them in, and we're going to associate each of those people, in this case, with a location that is going to be, again, going to be random. Often we don't want it to be random. We may want to have the location proceed by age, for example, and soon enough, we'll see in the boot camp how we can do that. But for now, we want them to be associated with a population which positions them at random locations. How am I going to? So I have a theory of personhood, which in this case is particularly stylized. How am I going to add them in? I'd like Kurt kindly helped to sort of formalize some aspects of this model, which had been formulating, but I'm going to do them in a distinct order, which I believe teaches principles, and I'd like Kurt to rearrange the write-up of it to reflect the order in which I build it. Okay? Yeah. So if you could rearrange it in the Google Doc, that would be great. Okay, so ladies and gentlemen, what am I going to do here to have a population of people? We added a theory of personhood, but what do we need to have a population of people? We need a population. And where does it live? In Maine. So let's go down Maine, and let's go drag in person into Maine, okay? Drag in person into Maine. Sometimes it bounces like a tennis ball, but we want to we want to drag it so that it sticks. We'll call it population. That's not particularly privileged. We could call it people. Some of my students are known to do that from time to time. But is this truly a population yet? No. What do we need to do? Yeah, we need to sit at population of agents. That's right, in properties. Okay.
Just a reminder, now that you've all made some changes, make sure you build it, save it. If you have any issues, grab a TA quick, because if you do a whole bunch of changes and then you build and you've got some other errors, then that's good.
Okay, great. Good. Okay, ladies and gentlemen, how are we going to have these people associated with a random location? We're going to later have them have a location defined by their age, but how do we associate them with a random location for convenience up front? Where do we go? Whither do we go? Yeah, initial location, and we're going to say in the specified point. This is not the only way to do it, but it's the most robust. And we're going to say, we're going to draw it from a uniform distribution. Now, I'm going to teach you something. I'm going to learn you something. Okay? Yesterday we said 0, 500. That 500 just happened to be the width of a common window. I actually want to distribute them between 0.0 and the width of the window. And there's an easier way to do that. This is going to teach some principles of how we compose these little formulae. So it's going to be this dot space width. Okay? This is what I'm putting in. I'm going to put it up on the big screen. This is what I put in. So what's going to happen here is it's going to call this, get the width of the space. Maybe it's 500, in which case it'll draw between a number between 0 and 500. Or maybe space width is 1,000. You can actually set this elsewhere declaratively without any code. And if this were 1,000, it would be uniform from 0 to 1,000. So rather than hard coding 500 and needing to go find it and change it, we're going to say whatever the space width is, go substitute that in there. So first what's going to happen is it executes this, gets a number, and then it's going to draw a number from between 0 and whatever that number is. And because this space width doesn't need any information to do its job, we give open paren and end paren. We call it, or requesting some information from it, but it doesn't need any information to do its job. By contrast, uniform needs two pieces of information, the minimum and the maximum. Do you see that? Yeah? Okay. Do you have that? Guess what we need to do for y direction? What do we need to do for y? Remember to use that control space. It will spare the TAs and yourself a great deal of grief. Notice actually there's a shorter one where you just specify the max and we'll go from 0 to that. If you want, you could avail yourself of that. Either one is an option. This is the same because one with just a single argument, a single number given is the same as doing it from 0. So I'll do that perhaps. It's recommended by brevity. But what do you think I'm going to give this? Am I going to give it the space width? No, the space height. Space, control space, and this will be space. Hey, come on. Space, and if we go down, we'll see space height. Boom. Do we need a semicolon after this? Yes.
I'm confused about something. Yesterday, sometimes we used this, but in the population we used self because the people were not existing yet. So
that's right. That's right. So this, and actually that is related to why we use this here. What is this referring to here? We're in main, so this refers to main. It's asking about main's width and main's height. if we wanted to refer to the agent's age, for example, we would use self.age. But we're actually asking about the height of the whole space, the width of the world, the height of the world. Does that make sense?
Yeah.
Yeah.
Well, so Nate, there's a question that other people might know. When you're talking about the width or the height, are you talking about that blue box, or are you talking about the person's?
No, I'm talking about the width of the whole area. And it's the window. You'll see it in a minute, okay?
So that would change then, depending on the monitor they're using?
Well, you can set it in the simulation how wide it's to be.
So you can actually go beyond the borders of that blue box?
Oh, you can. There's a logical space of conceptually unlimited size.
So there you go.
It's limited only by memory and, yeah, by memory and imagination. Okay. Yeah, so if you go to the experiment, you'll find there's a thing called window, and you can actually set it. You can set the properties you want to use for a given window. And, somewhere in here, you can actually set the actual width and height, I believe. If you can't do it with this anymore, you can do it elsewhere.
I think it's somewhere. It's in where the others do.
In Maine? Okay. I was pretty sure for a given experiment there's a way to do it, but
There is. I can't remember.
you can do it manually, but anyway.
Maine will change the blue box. What
Yeah.
simulation will do is change the size of the window that actually shows up when you run the model.
Yeah.
Okay.
Yeah. And so, for example, you could say maximize size here, and that will show it on the full screen. So maybe we'll do that, and now we'll see what happens, okay? So the second one was not space width, but space height, and I'll put that down here, okay? Just for those trying to copy my things. So it's going to determine the space height, and then draw something between them. And I noted that you could actually just do this. Draw a thing between 0 and whatever this number is, okay? So it's going to determine the height of the space and then draw a number between 0 and that thing. Okay, so let's run that. I actually clicked to tell it to maximize the window, and now the window will be bigger. And the area in which the agents, mumble.
Like when you run the model, the window will be full screen. It will show it like it did very briefly. So you close that and then you run it again. Yeah.
Well, yeah, but I want to actually. I see. It's with this
And
thing.
if
Yeah.
you want to change the window size
Yeah.
in
Yeah.
Maine,
Yeah. You could do it with me.
You
Yeah.
can do that in Maine.
Yeah. Yeah.
Just
Yeah. Yeah, we could do
space width.
here space width and height. Okay, so this is where we'd set. One sets the experiment window, which is a different window conceptually than the window associated with Maine. So if you wanted to check to make this, for example, 1,000 height and 1,000 width, we could do so in Maine. So whoever said Maine was actually quite correct there. The experiment window is a different window than the main window. Okay. So here we have a larger space, and agents are placed upon this space. Okay. Okay. So far, so good. Next, I would like to go lend this person some characteristics. Think about the O parties framework. We're going to have associated with this person an age. And we're going to have associated with this person some dynamics associated with their smoking and their heart disease. So in order to do this, I'm going to add into person not one state chart, but two in quick succession. So we're going to go into person, and we're going to go to the palette. And where do we go within the palette to find a state chart? Go to agent, and I go to state chart entry point, and I'm going to have something called smoking state chart. Okay? Now, a common way, there's two common ways of summarizing smoking status. One is ever and never, never smoker, ever smoker, where often never is operationalized as smoking fewer than 100 cigarettes in your entire life. Another common one is never current former, and we're going to use that, okay? Never a current former smoker. So we're going to drag in here a state, and here we go. Oops. Agent, we're going to drag in a state, and this is going to be never a smoker. The next is going to be current smoker. And notice I'm spelling them all in one word. Java is very unhappy if you try to use two words. You could use an underbar if you'd like to, but don't just try to make it into two words. It'll be very unhappy. So, former smoker. I use what's called camel case here, but some of you may wish to put an underbar between them instead. Great. Okay, ladies and gentlemen, where do transitions need to go here? Right now we have, what's that?
Between states.
Yeah, between states. Which state might go to which other state? If we want to think about someone initiating smoking, starting smoking, uptaking smoking, we use different words for it. Where would that transition be placed?
From never smoker to current.
Never to current, that's right.
From former.
That's right. So here we're thinking about characterizing a person's smoking status into categories. These are particularly common categories. It'd be from never to current, for uptaking, for initiation, for starting smoking for the first time. So we're going to say, we're going to call this initiation. Notice that, okay, so we dragged in a transition. I want to draw attention to two things. The first thing is I put the names of the states with a capital letter. That's by convention. It's nothing any logic enforces, but I think it's a nice thing so we can distinguish the two visually. And I'm going to name the transitions with the lowercase initial letter. And this is going to be called initiation. Okay? Thirdly, I'd like you to click, show name here. Show name. And that will allow us to actually see a name associated with this and to drag it around. Do you see that? Okay. Next, I would like to draw a transition from former smoker to, well, you know what? We should have been more careful. I'm going to do it from current smoker to former smoker. Make sure it turns green. Green is good. Green is the color when state charts are the game. Okay? So from current to former, this is going to be a transition which is called what? Cessation. This is the cessation transition, or quitting. And I'm going to click show name so I can drag this name and position it. Is that okay? Is that okay?
Yeah.
Okay. And next, we're going to drag a transition from former smoker to current smoker. What are we doing here? We're characterizing an individual's state with respect to smoking, with respect to that particular concern, into three categories. And now we're articulating the actions, and indeed the rules that govern those actions, and transitioning between those categories. So what would it be called if a former smoker falls back into current smoking? What might we use for that? There's relapse. So we're going to call it relapse. Relapse. Okay, here we go. And I'm going to do show name, and I'm going to drag this up here. Names are important, ladies and gentlemen. And showing the names is important. It's important for our stakeholders often to get an idea of what do you mean by that transition? What's the significance of it? What's the meaning that you have a transition from A to B? Okay. Ladies and gentlemen, this is good. This is good. So we have these transitions. Now I'm deliberately leaving something out. Have we specified the states? Have we specified the states here with respect to this concern? We have. Have we specified the actions that change those states? Yes. Actions involve movement between states. Have we specified the rules? A bunch of them, yeah. A bunch of them you can only initiate if you're a never smoker. It doesn't make sense to say initiated smoking when I'm a current smoker or even a former smoker. Initiation is specifically used in the tobacco community to mean starting smoking for the first time. Relapsing is only possible if you're a former smoker. You can't relapse from a current smoker state. You can't relapse from a never smoker state. There's no re there. So similarly, cessation is only possible in current smoker. There's certain rules captured. Good. Now suppose I wanted, and I'm doing this deliberately to teach some additional lessons. Each little exercise like this is designed to teach some lessons at several different levels of understanding. I would like to now have the person's color change. Suppose we wanted for a never smoker them to be green. And suppose for current smoker, red. And suppose for former smoker, what do you think? Sorry? Gray. Okay, great. Good. Okay, how would I do that? This is actually gonna be a thing you're gonna generalize in just a few moments to very powerful effect. I shouldn't say a few moments. In a few fives of minutes. It's a very good effect. How would I change their color? Okay, so in the population, we want different people to have different colors, but how am I going to actually affect a change in their appearance? How did we do that before? What was their appearance in the last model? It was governed by a what? As a variable that told the what to change color. The what within the person, the oval, okay? Ladies and gentlemen, we're going to have the same setup here. We're going to have a variable that's going to tell the person what color to be, with this little image, what color to be. Okay, great. So we're going to add in to this agent a variable, okay? We do so from the agent palette. We're going to drag in, and we're going to call it color with a U, okay? Okay. Yeah, you could actually copy. It's a good idea. We could actually copy that variable from yesterday's into this, and that would do that. Because we're not using an oval, it's going to be different in exactly where we put in the thing. But if you want to replace the little man with an oval from yesterday, you could do that. And actually you paste in both the oval and the variable from yesterday. And then what you would need to do is to just assign to that variable in these places, okay? And that could save you time. Yeah, we do that quite a bit. Okay, so what is remember when we specify a variable or parameter for that matter, we have to specify a so-called type. From what quantities is it drawn? What are the quantities from which this is drawn? Other, and it is color without a U because it's by American standards. Okay? It's not blank. It's black. Okay? Ladies and gentlemen, now, so how are we going to change that color? How are we going to make it green when they're never a smoker? What do we have to do? We're building up the muscles. Charles Atlas once said he became Mr. Universe by working up his 50-pound weakling muscles over time. Okay? He started without muscles and built them up. So it is here. So how are we going to change this color? How are we going to make it when they're in a never smoker state it's green?
As an entry action.
Yeah, entry action to never smoker. We have these handlers. These things come back again and again. Like comforting memories. Or like a horror show. They come back again and again, depending on your perspective on them. So, in the entry action, we'll say this dot color, my color, equals green. Do we need a semicolon or not? Yes, because we're saying do it. Make it the so. 50 push-ups now. Okay? Speaking of that, would someone mind getting me a tea? Thanks. Okay, current smoker. We're going to set it to be red. Notice I copy-pasted that. And sometimes things we do, well, you should be careful copy-pasting too much. And I'm going to say gray. Is it with AY or EY? AY, yeah.
Darn Americans.
No, I think that's a British.
EY is British.
Yeah, you guys.
Sorry, is it?
EY, yeah.
It's auto.
I have to accept it.
I think. Mid-Atlantic English. Well. Yeah. Mid-Indian Ocean or something. Okay, color equals gray. So we just assigned to that within each of these. Never smoker. We assigned it to be green. These are little patterns, ladies and gentlemen. These are recurrent patterns out of which we build models. You see these same patterns again and again. They show their faces. Hopefully those faces are friendly faces to you, but we reuse these little kind of ideas for how to represent things. Okay, ladies and gentlemen, so we assigned to these. How is this by itself, though, going to accomplish changing their color? What's missing? What's missing?
Right.
Okay, so we say that again?
Because we have to change the color for the shape.
Exactly. So we're going to need to engage in frobbing behavior with that gentleman or person. It's not necessarily a gentleman. It maybe it's of unspecific, non-specific sex. Okay, so it turns out that's a bit of a pain with this one, but there's an easy way to do it. You can engage in zoom and frobbing behavior, but my own preference is to go over to projects, go down to person, go down to presentation, expand person, and go to shape body there. And it spares you a lot of grief. Okay?
I don't know if they fixed it, but it used to be when you would specify, like if you, in the create agent dialog, like, you know, the window that comes up, if you specify, like you drag the person in there at that point, and when you first set it up, that thing would actually be a curve itself. It wouldn't be within a group. Anyway.
Yeah, I just don't like doing that, but yeah. Okay, so in shape body, under appearance here, we're going to go set the fill color to be the color. How are we going to do that? We need to change it to dynamic. These are the same basic rehearsal of exercises that we're going through, and we'll set it to be this dot color. Good. So if we run this model, what should we see? We will see something that will force us to pause and reflect on what we've left out. Does anyone want to predict what we see? You put you hit the nail on its head. Okay, so I'd like to run this thing. Can we run it? Why don't you build first? Make sure things are happy. You notice it says build completed successfully and there's no report of errors. So it thinks it understands what you mean. So let's go run main. Let's go down main and run, or let's go run the simulation. Okay? And here we go. What's going on here, ladies and gentlemen? Yeah, so they're engaged in rather synchronized cessation and relapse behaviors. Now, peer effects are one thing, but this is taking it a little bit to the extreme. So there's an issue here, ladies and gentlemen. There's an issue. We're going to now change these. You'll notice that this says initiation occurs, and we're going to come back to this. But I'm teaching a lesson. These timeouts mean that when they come in there, after exactly 1 year, they're going to start to current smoke. After exactly 1 year, this is the default here, they're going to go to former smoker. After exactly 1 year, they're going to relapse. Ladies and gentlemen, we need to change those assumptions. Now, there's two ways we could do this very readily. And then I'll come back to a second point. One way we could do this is instead of having a number here, we could draw this from a distribution. We could draw it from a triangular distribution. We could draw it from a uniform distribution, a log normal distribution. We don't have to use a number here for the timeout. We could draw it from an arbitrary distribution. Sorry? Oh. The second possibility is we could convert this to a different thing and specify a hazard rate, an initiation rate. And that's a common feature. For the sake of learning, I just want to change one thing at a time. Ladies and gentlemen, what's the average time it takes for them to become, this is a bit of a trick question, to go from never smoker to current smoker? What's the average time?
15.
Sorry?
15 years.
Oh, okay, but in the model right now, in its stylized form, what's the average time it takes? 1 year exactly. It's precisely 1 year. There's no chance. I think this is a dud. Oh, I'm surprised. Okay, so if we look at the probability of transitioning, or the probability density of transitioning, there's essentially no chance, this is zero, that they will transition before 1 year. And then at 1 year, they will transition. The density is actually unlimitedly high. And after that, there's no chance, if they remain there, that they would transition. So this is a totally memory-full process. It knows exactly how long they've been there, and it governs exactly when they transition based on that. We're going to switch this to a rate transition with the same average. This is going to have the same average time of transitioning, 1 year. How do I know that? Because the average time is 1 divided by the rate. This is a feature of exponential distributions. Some of you may know through your biostatistical knowledge. If your time in a given state is exponentially distributed, your mean time is 1 over the hazard rate of leaving. And here the rate is 1, and so 1 over 1 is 1.0. Okay. And we're going to do the same for cessation. We're going to change those to rates. And we're going to do the same for relapse. Everyone's going to have the same average amount of time to go from never smoker to current smoker, from current smoker to former smoker. But now the situation is totally memoryless. It doesn't matter how long they've been there. They have that same kick of the can chance in the next little bit of transitioning to this other state. No matter how long they've been there, they have that same chance of transitioning in the next minute, hour, second, if they have been there 10 years or if they've been there 10 seconds. That's a rate. It's memoryless. It's associated with an exponential residence time. Okay? Incidentally, this is what's typically used for stocks in system dynamics. We have a first order delay, and it's assuming an exponential resonance time, and it's memoryless. So now we've changed this. So far from being precisely determined by how long they've been there, now no matter how long they've been there, their chance of transitioning in the next little bit is the same. It's a constant. A constant has a rate, conditional on still being there. Their chance of leaving in the next minute, hour, second, whatever time you want to use to specify the hazard. It's the same, no matter how long they've been there. It's memoryless. It doesn't matter how long they've been there. It's the same kick of the can. If they're still there, they have that same chance. So what do we expect to see now if we ran this? Speak on. Now we see people are blinking. What's going on? Same average time to go from one state to the other. Same average residence time as a never smoker, as a current smoker, former smoker. Why are they all desynchronized like that? Well, there's no synchronization because some go earlier, some go sooner, some go later, and they're not paying attention to each other. This afternoon, courtesy of Winchell and Kurt, you'll be introduced to ways they could care about each other's status. But right now, they're all independent. But we're preserving this sort of average time. We are going to, ladies and gentlemen, leave that in place for just a moment. We'll come back to that. But first, I want to take you to a place that you have yet not gone. A place of discovery. And for some, a place of delight. Okay, so I'd like to drag in a state chart entry point, and I will call it heart disease state chart. And this heart disease state chart will consist of two states. So we'll call this healthy. Healthy. Maybe we'll call it no heart disease to be more specific. No heart disease, and we'll call it with heart disease. They have heart disease. And we'll have a transition between them that we'll treat as a rate transition. We will call it developing heart disease, and it will be given by a rate, and the rate will be 0.002. So on average, it'll be 50 years, 1 divided by 0.02 years before they develop heart disease. So each of these state charts, characterizes their state with respect to a different condition, different concern. This state chart characterizes their state with respect to smoking. They could be in any one of the states. Meanwhile, this other state chart specifies their condition with respect to heart disease. They could be in either one of those states. They could be a never smoker with heart disease, or they could be a current smoker with heart disease, or a current smoker with no heart disease. Any combination, but we don't have to specify possible combinations as a combinatorial thing. Rather, we specify each one in terms of that concern, and then we will put into place, after the break, an interaction between them. Are we okay with that? Okay. Okay. Good. Now, we'd like a way of characterizing their heart disease status visually. Ladies and gentlemen, and this was the reflection that I neglected to mention earlier, but it crossed my mind that I should emphasize it. Ladies and gentlemen, visualizations of models is not merely a matter of eye candy. When I was young, and I delighted in technical tweaking of low-level code. I saw visualization as kind of a fluff. I understand that in Russia, a lot of people refer to the visual interface associated with the program in a derisive fashion. Some of the programmers who like to strut their technical prowess call it the snout of a program. It's kind of the ugly part of it. The real beauty, they say, lies within, and the snout is just the ugly thing you have to deal with to interact with the external world. Fortunately, AnyLogic has not embraced that philosophy, or at least not completely. But I'm wholly in disagreement with that philosophy. I'm wholly in disagreement. I profoundly object to the characterization that users are to be simply pushed with the snout of a program, and that the real essence of the situation is internally. Users make or break the viability of a simulation model to make a difference. And here, ladies and gentlemen, even for the modeler themselves, so for stakeholders, seeing a visualization often is the difference between understanding what the simulation model is accomplishing and what it's not. But for us as modelers, for those working in the modeling team, building the model or just interacting with it, changing it, understanding it, visualization is hugely powerful. It lets us spot patterns of what's going on in the model that we would have noticed otherwise. It lets us spot problems much sooner. It lets us understand at a deeper level what's happening in the model. We spoke earlier of the need for models as learning prostheses because our brains, even of an Einstein, are profoundly limited in their ability to put together all the moving pieces and say what's going to happen over time of a even modestly complex system, much less a rich system like we're often dealing with. And yet, our brains are exquisitely suited to noticing visual patterns, to parsing what's going on visually and recognizing interesting phenomena through our visual cortex. We're very well adapted to that. And visualizations, such as we'll be making use of, can really aid us in our understanding, our intuition, in heading off problems, in communication, help us advance our modeling project in a more savvy and more fulsome fashion. So I would like to turn this heart disease, no heart disease, into some visualization. So we lend people an appearance based on whether they have heart disease or not. Now, there's two ways we could do that. Lend them a color. We could have a separate color. We could have a fill color, and we could have a surface color. But there's only two states. So I'm going to accomplish this in a different way. I'm going to go over to projects. I'm going to go down to shape body again. How do I reach shape body? I go to person. I go to presentation. I go to person here again. Hey, get over there. And I go to shape body. And you'll notice there's fill color, but there's also line color. Okay? Line color here is something that will specify the sort of surrounding features of the person. And we're going to change it to dynamic value. And instead of doing it through a variable, we're going to do it through a simpler mechanism we used yesterday. Does anyone remember for males and females, when we just had that dichotomous distinction, what did we do? Okay, we did for the income, that's right.
List.
Yeah, and for color, what did we do? We actually did something very, very similar. Exactly on it as normal Gabriella. We basically had a conditional here, sort of an if-else. If they are male, then one color, otherwise female, or otherwise another color. Do you remember gray and yellow? Okay, we're going to do something similar, but instead of asking if they're male or female, we're going to ask, are they in this certain state? Okay, we're going to ask, are they in a heart disease state? If so, their surrounding will be mumble. The surrounding will be blue. Otherwise, it will be black. Or do you want to make it red as well? Okay. So let's do green and not green. Green is already used. Sorry? Purple. Magenta? Magenta. Okay. I learned a couple months ago what magenta is. By my 50th birthday, I want to learn what fuchsia is. Okay, so for the line color here, I'm going to say this dot in state, and I'll ask, are they in this state of heart? And actually, I'm going to say person dot heart disease. It's heart disease with respect to a person. One of Cheryl's colleagues in the Western College of Veterinary Medicine studies chronic disease in dogs, Lynn Weber. And you can talk about heart disease in dogs, and you can talk about heart disease in people. So we're indicating here it's the type of heart disease that applies in person. So when we name a state, we often want to indicate the agent in which it's located to be very clear. So if we have multiple types of agents, a service dog and a person, for example, we can refer to, distress state in a service dog versus a distress state in a person. So if they're in a certain state, does anyone remember how we do this kind of if-else logic? What do we put? Yeah, okay, well, that double equals is to check, but we do something else. It's I heard it. Question mark. A question mark, ladies and gentlemen. So this is actually going to be true or false. Are they in that state or not? If they are, we are going to make them magenta, that line color. Otherwise, we're going to make it black. Fuchsia. Oh my gosh. How do you spell it? Oh, fuchsia. It is there.
It's there?
Oh my gosh. Okay.
If you're wondering what colors
They
are
will look
available,
the
you
same.
can just click on one of the states and go to color, and it'll kind of give them all to you.
That's true, but I might not recognize fuchsia from ochre,
Yes, I think you did.
or from mauve. Okay. So magenta. Are those different enough to distinguish?
Not really, no.
No. Okay.
You lime green.
No. We already have green.
Blue, turquoise.
Turquoise. Okay.
Teal.
Turquoise. Dark turquoise. How about that? Is that okay?
Yeah.
Or yeah. Okay. Dark turquoise. Okay.
Maybe a little hard to see, too.
Oh,
That's what
teal. Okay. 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 Sorry, I'm in over my head here. Okay. Okay. Ladies and gentlemen, we built, and it indicated success. There's no indication of errors. I'd like you to do the same, and I'd like the TAs to monitor. Who needs TA help? Who needs TA help? Okay? I'm amazed at your resilience. And equally amazed at mine. Okay, here we go. Ladies and gentlemen, now we see people moving around. Okay, dark turquoise is a little bit hard to make out, but I guess it's that bluish color. And here's a magenta. Magenta is someone with heart disease and so on. But ladies and gentlemen, right now we have them evolving in these two different solitudes. So a given person here, do you see this? A given person here is in a certain state with respect to heart disease, a certain state with respect to former smoker. Watch them oscillate back and forth as they quit and engage in relapse. And they're popping back and forth. Notice in heart disease, this person has remained heart disease free, but in the fullness of time, the ravages of age strike, and they develop a heart disease condition. So, ladies and gentlemen, I hereby declare a break, and we will return in 5 minutes, and we will. Okay, 10 minutes. Jeff, look pained. If you think this boot camp is bad, you should have seen our first ones. Jeff was standing where Iden was, and he said, this is, I think, our second boot camp. He said, I think I am drowning in a sea of information. And I knew I pushed things a little bit too far. So ladies and gentlemen, 10 minutes. 10 minutes to obtain your coffee, to obtain your sweets, and we will come back and we will hitch up our heart disease state chart to our smoking state chart so that the risk of developing heart disease is greatly magnified by your current smoking. Okay? And if there's demand for it, we will further have age-specific initiation rates, and we will further have heart disease rates that depend on how long you are smoking, not just your current status. Okay? Thank you very much.